ad playing, so I'm not really going to do anything for the first 30 seconds. And I'll download this and cut it out before we get stuck in with what it is that I'm doing. As usual, I'll just disable my little feedback window. There we go. It's a bit distracting. And so this is a bit of an experimental stream because what I want to do is I thought it would be quite interesting to document the process that goes into one of making my videos. So I've come up with an idea for a video which I want to release in a couple of weeks, and it might surprise some of you out there that actually there's quite a bit of work that goes into one of these videos before I make it, and I thought it'd be interesting for me as a bit of a personal record of the process that goes into it. So we'll just make sure some people are here. Who have we got? Danicon, yes, a stream, hello. Bit of a strange stream, this one, so we'll see how it goes. And the purpose of the stream is, I'll probably end up repeating this several times as people dip in and out and don't really understand what's going on. I'm going to sort of document how I make one of my videos, and it's really from scratch. So right now, all I've got in my head is an idea and some thoughts that I want to try tonight to start some of the code. So this will probably be part one of several live streams before I then finally make the video and edit it and publish it to YouTube. And I think maybe the YouTube videos are edited in such a way, I have to remember where the camera is here, I'm looking at the wrong camera. The YouTube videos are edited in such a way that it looks like it's all come together very cleanly and easily, and you know, sometimes it does, but not every time. And there is always a bit of process and preparation work required to make sure that an idea is correct. Magetsub, hello. And so the next video, the idea for it, is I wanted to do something about image processing. I just want to see, what have we got? Prankster, thank you. Yes, if you're wondering why I look over here when something comes along, it's because all of my information is up there. Also, because it's going to be image processing, I know I'm going to be using my web cameras, so I'm using my very cheap action cam to film me, and that's why there's about a second delay between the audio and what you see on the webcam. But rest assured, it is actually very live. It's not your system that's broken. When I was at university, one of the things I was interested in was the human visual system and how it perceives the world around us. And I went on to study a fair bit of neuroscience, and we created models of how the brain processes things through the retinotopic sort of visual cortex structure of the brain. And as a side of that, one of the things you need to do is sort of validate and prove your work. So even though it was very sort of brain related, it ended up being a lot of machine vision related too. And that's because you wanted to test your ideas. You had to work with realistic hardware such as cameras and sensors and things, and make it work. So even though we were studying the brain, we still needed to rely on non-brain materials in order to do that. Chris, hello, welcome. And so tonight I'm going to start formulating the ideas behind what I want to do in a video called 8 Bits of Image Processing You Should Know. It heralds back to some of my very early videos where I would talk through 8 very brief snippets of code and suggest why they're quite important. And you might be thinking, well, image processing, that sounds really boring. You'll be surprised how often a bit of image processing can help you in your game applications and beyond games too, because images really are just arrays of data, and it's about working with arrays in a spatial sense and sometimes a spatiotemporal sense. And there's some useful attributes there which can be applied to not just the obvious things like textures and graphics, but also procedural generation and filtering of information. Sometimes you've created an array of data, but you just want to take the rough edges off it, even though it's not an image. So image processing will actually have techniques which are useful to you there. So yes, it's just a blank screen at the moment, and this is exactly how I start my projects. Now I'm going to be using my primary webcam, which is up here, as a vision source in the application that I'm going to write. Well, at least I think I am. I mean, this is the point. At the moment, as you can see, it is a blank screen. All I've got so far in my Visual Studio solution is the Pixel game engine. For some reason, the sound API, we can get rid of that. We're not going to use using sound. And I've loaded in, because I might need them, the webcam drivers. And when I'm creating a video, the first thing I'll do is this idea image processing. So I'll create a C file, or C++ file, called whip-imageprocessing.cpp, and that means work in progress image processing CPP. And I'll work on this until it graduates until it's an idea or a fully formed video. Hey Dragoneye, yes, a coding stream for a bit of a change. Right, so 8 bits of image processing. Well, I guess the first thing I'm going to want to actually pull up is what are the 8 bits going to be? I mean, you think, if I ask the man on the street, what do you know about image processing? Can they tell me 8 different things? I'm just going to move a window here. I did last night, full disclosure, I did last night actually start to just play with some webcam code, and that's what I've got on a screen over here. And I might... so this is a little structure just holding some arrays. So I'm going to borrow some of those ideas, but I wasn't happy with how that went in the end. So it's not a complete start, but we're going to start pretty much from scratch here. So the first thing I'll probably want to do before anything is actually think about the 8 bits of image processing that I want to include. So bit 1, I think most fundamentally, is something called a threshold operation. And in the final video, what I'll do is I'll present one of these at a time and write some code and show the effect, and then perhaps give an application or a use for it. But right now, let's say this is a sort of a documentary video about how I go about making one of my regular YouTube videos. And so after thresholding, we've got to remember we've also got to do these in a way that's approachable, because if somebody's watching this video and they've never seen any image processing at all, there's no good me jumping straight in at the deep end with sort of complex Gaussian based algorithms and two-dimensional fast Fourier transforms and things like that. Also, that would make the video very long. I've got 8 individual topics I want to talk about. I really don't want to spend more than 3 or 4 minutes on each one, or else the video becomes too long. And people don't get into it. 8 bits per channel. Ironically, yes, it will be 8 bits per channel because you do most of your image processing in the grayscale domain. It turns out there's not actually very much information in color images. I mean, obviously there is. There's 3 channels worth of information, but from a what we call a morphological perspective on image processing, you don't really need the color. Sometimes it's useful to get you out of a hole if you want to classify objects and you need that sort of additional texture information. But most image processing comes down to working in a binarized morphological topology or in a very simple 8-bit grayscale channel type thing. 8 bits of DSP you should know when. So yes, this will be obviously going on the Javid X9 extra channel as a bit of a background. I'll probably do 2 or 3 of these streams over the next couple of weeks, just wanting to record the whole thought process and as we develop the code. So I really don't know where the code's going to go just yet. But thresholding is probably the first operation, and obviously I'll talk through these as we're going, but I just want to try and get some basic bits out. So the second one will probably be motion detection. And this is a nice one to put in second place because thresholding is very simple, as we'll see. We're basically just going to look at a pixel value and decide should it be black or should it be white. Motion detection is a little bit more complicated, but we can build on the framework that we've already got. Because there's a bit of a tricky one with this. I'm going to have to start the video with a very quick rundown of what the structure of the program is and how it works. Or maybe not. Maybe I just jump straight in with the techniques and say, now you can download this program and play with them yourself. Who have we got in the chat? Slice and Dice, hello. Sistran, hi. Awkward name I can never pronounce. Glurax, hello. And Heart Attack Man. Well, I hope you don't have a heart attack today. I think we've just got a notification there. It's behind my screen. Ah, Perpeto, thank you for the follow. So motion detection is quite an easy one too, so we'll try and ease the viewer into it. The next bit I want to talk about will be erosion and dilation. Oh, I've got to spell these things right, haven't I? Dilation, there we go. And then I'm going to follow that up, and this is where I'm getting a little bit worried, because now, do I want to go down the maths route, or do I want to just try and keep it all very high level and just show the effects? But I think you can't do image processing without convolution. And I'll probably need to come up with some demo for, not convulsion, convolution. Convolution. Oh, there we go. I've not woken up yet, and this is how all the videos start. It's just me spamming text at a screen, really. After convolution, now maybe I should just quickly explain what convolution is. Convolution is the approach of taking a spatial filter and applying it pixel by pixel across the image surface. Who have we got? You remember convolution from school? Yes. Convolution is actually applied in lots of different disciplines, not just image processing, but it's basically applying a filtering kernel to a data set, but quite useful. Now, once we've got convolution, we've then got a whole stack of different things we can do. So I think probably sharpening algorithm might be quite nice after that, because it's visual, it pops out, it's something that I can show on a camera, and it's going to people will see that I've sharpened the image. So maybe to sort of counter convolution, or to counter the sharpening perhaps, and maybe the easiest kernel is probably just a blurring kernel. So we'll put in a blurring filter. Now I need an example to show convolution with, so that's probably what I'll choose to do. For the 6-bit, after we've done sharpening, maybe something like a median filter. Maybe. Don't know. These might change the order a little bit. I definitely want to get in some sort of edge detection mechanism, so we'll have some Sobel in there, because we'll need to know how to do convolution before we can look at Sobel edge detection. And finally, I have a sort of a little scratch out list here. I've got a couple more. So I've got too many. Probably better to have too many than too few. One will be an adaptive threshold, and that's different to a regular threshold, because a regular threshold where the threshold point is chosen based on the data surrounding the pixel that you're trying to binarize. Finally, 9. Adaptive threshold. Don't know, I'll go and have a look at my list of potential things. Which on my list should I choose? Oh, why not? Yes, we've not done any sort of temporal filtering, so perhaps something like low pass filtering of the image. So we've got certainly lots of things to talk about when it comes to image processing. I can certainly find 8 bits of interesting things to talk about, but now I need to be able to present it in a sensible way, and this is where the challenge really comes in the videos. I could go ahead and write code like I would do at work, but then people wouldn't really be able to follow it that easily. It's a bit industrial. So it's now about finding an appropriate mechanism to display images, and make it so that when people look at the code, they'll look at it and think, well, actually, yeah, I can see how simple the image handling side of this is. The algorithms for these individual bits might be quite complicated, but what I don't want to do is have them bogged down in the rest of the peripheral code in order to display the algorithms. So I think we're probably ready to start doing some sort of coding. So this is my int main. And I'm just going to start by thinking about what kind of data I'm going to have in here. Let me just quickly catch up with some of the chats. That's 1 bit over, yes. 0 to 8. You should have 2 versions, 1 industrial, 2. Yeah, but I don't want to write sort of industrial code when I'm not at work. I'm going to have a mouthful of code. So it's busy. So I know quite a few people have joined the stream now. I was going to call it the chat then. They've joined the stream. Just to fill you in with what's going on, this is a little bit of a background documentary video stream thing that I want to do about how I go about making one of my YouTube videos. And it's just going to go from this idea, and we'll slowly develop the code into something a bit more usable. So I think, and people on the Discord last night will find that we discovered a bit of a bug with the Visual Studio compiler, and it was whilst I was trying to create a frame object that might represent some of the images. But let's just get stuck in with a simple representation of a frame. So this code may have been seen by a few people on the Discord last night. I need to give the struct a name, don't I? So a frame is really just going to be a two-dimensional array of data. And I think for all of my applications and all of my demonstrations, my frames are all going to be the same size. I don't want to bog it down with width and height and that sort of thing. So I'm going to define at the top of my program two consts, which are going to be n frame width and what's my webcam resolution, 320, and n frame height, which is 240. There we go. So my frame is going to consist of, well, when we're doing images, what do? We usually have an R and a G and a B channel, but I know that for my image processing videos, I'm not interested in colour. They're going to be grayscale. It's going to be a bit of a gloomy video visually, so perhaps have to think of some way to colorise it better. But I really just want so per pixel, just one channel. So I'm going to also stick with floating point. And I think I prefer floating point because if I went with integer, then you start having sort of the integer division kind of issues that might crop up. And that will give you some interesting artifacts, which I don't want to have to explain in the video. I'd rather just get the point of the image processing technique across. So let's have a look. What have we got? Do you sometimes do a Q&A stream? Yes, I did a really big one on YouTube about 3 weeks ago. It was 3 hours long. So I'm not going to be doing another one anytime soon. But feel free to shout out in these things. That's okay. These are very informal. So I know in here I'm going to have a floating point array, and I'm going to call it pixels. And all of my frames are going to be the same size. So whenever we create one of these things, let's throw in a constructor, I want to create the size of my array. And this was the bit of code that caused some problems last night on the Discord, because of the way I was initializing the array was crashing Visual Studio. We'll see if it does it again tonight, but let's see. So it's going to be a new float, and it's going to be n frame width times n frame height. And well, because I get letters, people write me letters. Let's tidy up the memory as well. Put a space in the Visual Studio. Come on, help me out. So whenever one of these structures exists, it's going to create an array, and it's going to delete it as soon as it doesn't exist anymore. Yeah, it was 3 hours because at the same time I was building a robotic arm. So there was lots to see visually, and for those that really were interested, they could listen to whatever waffle I had to talk about. Right, so we've got a frame. Let's zoom out a little bit so I can see a bit more of the screen. And we've got a height. We've not really got any sort of program yet. So no doubt, obviously, I'm going to use the Pixel Game Engine to start displaying these things. So maybe that's what we hit next. Let's bring in the Pixel Game Engine. So when I do Pixel Game Engine applications and I'm starting from scratch, the first thing I always do is just cut and paste this bit, which is in the Pixel Game Engine header file. I'm going to throw that in. It's going to give me a main I don't need. In fact, I'll keep the main it's given me and get rid of the one I created. There we go. So this is the default Pixel Game Engine file. I'm just going to smash the compile button now and see what happens, just to make sure it's all come in. And so if I play that, yeah, we've got random pixels. Good. That's nice. Good. Then I'll get rid of all of the junk that I'm not interested in seeing. I've seen it too many times. And I suppose we should name things appropriately. So right now it's a work in progress, so image processing. And we'll just replace the relevant bits, just so I know what's going on. Now, how am I going to present the information? Well, I think when you want to demonstrate the effects of an algorithm, you need to see a before and an after. So probably I need to display a frame on the input side and a frame on the output side. Now my frames are 320 by 240, so I know I'm going to need a pixel game engine which is 640 by 240. That's only if I only want to display 2 frames. Well, I think for now, I mean, it's easy enough to change later on. Perhaps I do only want to display 2 frames. Yeah, people do get a bit touchy about memory. So, okay, let's set up the console game engine to be some sort of appropriate size then. So what would we just say it was? 640 by 240, and I'm not going to be able to fit 640 times 4 on my screen, so I think we'll just have to go with a 2 by 2 in this case. We can try 3 by 3 later. Of course, we can also try full screen mode as well. So let's assume if we are trying full screen mode, then I'm going to need a way to get out of the application. So let's just quickly throw that in. Get key, OLC, key. Oh, I don't need to put the key in, do I? Do I need to put the key in? I can't remember. Yeah, why not? Put the key in, escape. Right, so if the escape key is pressed on that frame, then we're going to return false. And the application will exit. Because if we go full screen, of course, we've not got any X's to click to shut things down, so it can be a bit awkward. I also don't know how well the full screen is going to work with, given the fact I've got 2 cameras up and running, and I've got OBS encrypting things and sending it all over the world. Right, so I've got a pixel game engine. I don't like that being sort of stuck in the middle of my program, so I'm going to move that up to the top. And we've got a frame. So I think we probably want the ability to draw the frame. So let's go into On User Update where I would normally draw things, and I'm going to clear the screen. And I always like to clear the screen now to dark blue. The reason I choose dark blue rather than black, well, my images are going to be grayscale. Oh, I don't even know my own syntax, do I? I've got this all back to front. The images are going to be grayscale, so it's a very good chance some of the pixels are going to end up being black, and perhaps you're not going to see where the image boundary is. Also, it makes the thumbnails look a bit better than everything being on a black background. I was looking at all of the videos on the channel that's sort of in one hit. It was a very gloomy, dark channel when it comes to the thumbnails. So dark blue as a background is probably about right, but if I'm displaying both input and output images, I'm never going to see any background. So I don't really want to display them without seeing that border, which means I need to put a border around my images. So let's put a 10 pixel border around both the input frame and the output frame. So that means I've got 10 on the left, 10 in the middle, 10 in the right. So that's actually a 670. And I've got 10 at the top and 10 at the bottom, so that 240 becomes a 260. Okay, let's just have a quick boot up and see if the dark blue is sort of the effect I want. And how big is the window? So the window's a bit of a sort of a long, oblongy shape. Okay, maybe we can then put 2 by 2 images on. We'll worry about that later. So I probably want a function that can draw the frame to the screen, rather than having to do it multiple times, because I might want to display the frame several times in several different places. So let's do that. Draw frame, and we'll pass in the frame, and we'll give it a location. So draw frame, and all I'm going to do is iterate through all of the pixels in the frame and draw them to the right location in the screen. And of course we've got some fixed locations. I can't use X and Y here. So for int I equals 0, I is less than n frame width, because made this assumption at the start of the program that all of the frames are going to be the same dimension. And we need to do the same for the y-axis, which we'll call j in this case. J equals 0, j is less than n frame height, j++. And we want to draw, and we're just going to be drawing the pixel in the frame at that location. Just having seen, this is the thing, this is as I'm coding these things, I'm thinking of it as I'm going along. So do I just want to draw? I mean, obviously the frame is going to be in floating point format, and of course the draw command accepts OLC pixel types. However, we're going to draw to x plus I and y plus j, so that'll draw it in the right location on the screen. But now we need to sort out what the colour is going to be. Col. Right, we'll have to have a think about that, because I think we need to do some conversion. Because when we're doing things in the floating point domain, and with image processing in general, it's often a lot more convenient to scale things between 0 and 1 rather than 0 and 255. 255, in the scheme of it, seems a bit arbitrary. So I probably want to multiply my floating point pixel value by 255, of course, to give me the appropriate grayscale colour. But what happens if the pixel values are less than 0 or above 0? So I need to clamp the pixel value so we don't end up drawing weird colours and things. Have a quick glance at the chat. The sync problem is my fault. Don't worry about it. It is not a problem at your end. The webcam I'm using for my visual appearance is a cheapo little action cam from Amazon, because I can't get it to work with the Escape library that I really like for webcam holding, and for whatever reason the sound and the audio is not synced, so I don't think it's the end of the world. So it's not a problem with your end, it's not a problem with Twitch, it is a problem at my end. Right, so we've got a frame with some pixels in it. Pixels, there we go. And we know that the location of the pixel is going to be j times n frame width plus I, in this case, assuming I is x. Yes, it is. And what I want to do is somehow turn that into a pixel. Well, first of all, we know we need to go from floating point to an integer, so we'll call it int c. We know that we're going to scale this to a full color range for a single channel of the image. So that's the first thing, but then I want to clamp it as well. So I think I want to make sure if it's below 0, we stick at 0. What do we want? We don't want minimum if we're checking for below 0, do we? Want the maximum of 0 and whatever the result is there. And I think we want the whatever's left over, because that could then give us 300. We then want to check the minimum between what all that is and 255. I've probably got all of that in the wrong order, but the intention here is to clamp my scaled floating point pixel value to between 0 and 255. And then I can construct my pixel, OLC pixel, and it's grayscale, so we're just going to say RGB. We'll not worry about alpha at all. So I'm already thinking, this is stuff, do I need to describe to the viewer in the video, or do I just take it for granted? This is one of those things we're talking about image processing, not the code behind how we show the image processing algorithms, because all of this is technically irrelevant to the image processing. So we've got the ability to draw a frame. Let's add a couple of frames into our project. I'm just going to stick those here. Frame. We've got an input and we've got an output frame. Now hopefully when they come into existence, they should just go away and construct themselves and become two-dimensional floating point arrays of the appropriate size. They'll be full of junk. But let's just test if our draw frame routine is drawing them in the right place. So down here. Draw frame input. We said we had a boundary of 10. Was it 10? Was it 10? It was 10, wasn't it? 10 by 10 pixels. So we'll draw it from the top 10 by 10 pixels in. And next to that, we want to draw the output frame. Draw frame, output. What did we say it was? It was 320, but plus the 10 on the left and plus the 10 on the right makes it 340, comma 10. So what I'm aiming for here is a blue boundary around both an input and an output frame. So let's take a look. Let's see how much have I got horribly wrong by now. Well, it looks like I've got something not quite right. So I've got 10 on that side. Did I added too many on? Oh, 350. I did actually say 340, didn't I? There we go. And yes, okay, so we've got an input and an output frame. No images just yet, but I did notice that when we were compiling, we got some sort of warning. I think I glimpsed at it. Yeah, it's warning from whatever that is to int, which I'm guessing is after all of that. Yes, so I'll just silence that warning. Very good. It's no good if I create code and then it goes on the GitHub and people download it and compile it and go, oh, Javid, it's full of warnings. Are these all going? Because then I end up with nothing but an inbox full of people asking me about these warnings. I've learned this mistake from the very first video when I decided to use Unicode. So I'm now afraid of trying anything that slightly breaks the rules. So I've got my two frames, input and output. Let's grab some stuff from the webcam. Now off screen, I'm not cheating. What I've got is the code from the webcam at the console application. So I'm just going to cut and paste from that, I think. Let me find where that code exists. Right, oh yeah, we needed a fair bit of stuff, didn't we, to pull in the webcam. So the first thing we wanted to do, and I've included it in the project, but we do need to include it here, is to include Escape, which is a library that just allows you to quickly grab stuff from the webcam. And then you needed some peripheral structures to make that work. So I'm going to just bang those in here. So you needed this is purely stuff that makes Escape work, so nothing too relevant. And I'm just looking for where I capture the image. There it is. Oh, I need to set up the camera first, don't I? No, which was on user create. It's like it's all backwards and upside down. On user create, initialize webcam to console dimensions. Well, it's not a console anymore. Oh. Conveniently, I called it frame width and height back then as well. Funny how these things stick. So initialize webcam to set up console dimensions. It's not the console. And it's by default going to look for camera 0, which I'm hoping is going to be the webcam on the front of my TV. I'm also hoping there's going to be enough light to see if any of this works. So we've set up the webcam, we've grabbed its image, we've not grabbed an image file, but we've given it the memory that the driver required, and we've told it to go ahead and initialize the webcam. So we do need to capture the frame. Let's have a look. Where did I capture the frame? In fact, capturing the frame is a little bit of a mess by the looks of it. I'm just going to copy that bit because the rest of it's all console stuff. So in my onUser update function, before we draw stuff, first thing I'm going to do is capture the frame. So it's do capture. We've just set it all up with the width and height and things. That's fine. And then I've got this nested for loop, which will give me the format of the image in RGB pixels. Unfortunately, it's not the same as an OLC sprite. That was a missed opportunity, wasn't it? But what I want to do is take one of these elements and populate my input frame with it. So I think it's just input. What have we got? Y times n frame width plus x equals. Yes, I don't know what a Linux alternative is at the moment. You just have to run with it. This, as I say, as the weeks go by now, well, 2 weeks go by, I guess. Yes, 2 weeks go by. I need to sort of think, well, yes, what about the Linux audience? What about the Mac audience? What about anybody else that's going to be using the Pixel game engine? And it suddenly doesn't work for them. But right now, that's not my concern. My concern right now is just making this work. So that's going to give me an input. I'm just looking at the console code I want to get. I'll take the green channel, which is the one in the middle. So C1, and that's obviously going to be between 0 and 255. So I'm going to divide that back down into 0 and 1. So we're normalizing the pixel. Oh, input dot pixels, isn't it? That's it. So pixels is actually the array within the frame. And it may turn out that I don't need the frame structure. Why are we still whinging here? What have we got? Oh dear. See, this is the warts and all side of how we make videos. You get lots of mistakes. That's better. So I've captured the webcam image into my input. Let's just see if that works. Hopefully it finds the right camera. We'll click compile and we'll click run and we'll see what it sees. Oh, perfect. So what you might ironically see is that the sync problem has gone away now because it looks fairly synced with my voice. So that's obviously me. Hello. And that's our input image. And I've not got much light in here, so it is quite noisy. Now that might be a good thing because I can exploit the fact that the image is noisy as part of some of the image processing algorithms. Yeah, somebody could suggest perhaps a Linux alternative that doesn't require 100 million libraries pre-installing. So we've got obviously a picture of a pretty programmer there. I've got to say that 5 times fast. And we've got an output window. So it'd be good to be able to set the output to the input. Now, one way to do this is to sort of mem copy the pixel data over. That seems a little inelegant to me. I think what we probably want is to potentially overload the assignment operator. Now, there's a risk to doing this because if I go down that route, do I then in the final video have to include, well, this is how I'm assigning the images, this is how I'm implementing sort of all of this peripheral back-end stuff? Or do I find a really simple way, which isn't the best way to do it, but when somebody looks at the code, it becomes very intuitive as to how I'm copying one frame over to the other? I think for my sanity right now, I'm probably going to go down. So I'm looking at some of the chats. Who have we got? These 2 images are decent. Yeah, the top right webcam corner, one in the corner, is about 2 seconds behind, I think. So do I want to do some sort of assignment operator? Why not? Why not? Well, let's just do it. I don't want the video to become about this though. So what do I want to do? Void operator equals, and we've got to remember these things. Const frame f. And what are we doing? We want to copy the frame coming in pixel array into this object's pixel array. So this pixels is going to be one of the things that we need. Mem copy is going. People don't like mem copy anymore, do they? Mem copy this pixels, and the source is going to be f pixels, and the size, because everything's fixed, keep it simple. Width times n frame height times float, of course. Why is it whinging at me? What's it saying? Expression must have... Oh, yes. Yes, it should. So, that should allow me then to cleanly output equals input. Fingers crossed. Rather than having to sort of implement a mem copy every single time or have some sort of function. I quite like the clarity of that. But it worries me that I've then got to go and explain how this assignment operator works in a video that's not about code, it's about image processing. Let's take a look. Ah, stereo Japid. Perfect. Let's catch up with the chat. You were trying to move the mouse from my picture. Those two images are definitely not desynced. Awesome. Oh, thank you, Resident Vitality. Dragon Eye with traditional Dragon Eye typos. Always exciting. Oh, we can see my microphone down here. Very nice. So let's just for now let's do threshold. Why not? Threshold is very simple. So where am I going to implement this? How am I going to present this to the user? Do I want to create a threshold function? Am I just going to throw some code at the screen? Why not start just by throwing some code at the screen? And we can always wrap it up in a function later on. Just spotted something. So that's going to be not very useful because I'm drawing the input and the output, but then I'm setting the output to the input on the previous frame. So they were actually out of sync by one frame. So I must remember to do all of the image processing here before I get to here. So time to add some useful comments. Draw stuff only here. And we'll just fill this one in. This is capturing webcam image. Now in the source code that I put up on the GitHub for the individual videos, I do tend to go through it afterwards and tidy it up and try and comment all of the bits that I think need a little additional explanation. So we'll put image processing here. So let's start with a simple threshold. So bit 1, threshold. How I package these things up, I'm not quite sure. But a threshold is reasonably simple. We just need to go through every element of the array. So that's going to do just that. And for our output, I'm going to get a bit tired of typing X and Y and width and height all the time. I'm also a bit concerned later on because I'm going to get to some algorithms which are going to do things near the boundaries. So I might take this opportunity to put in a get and a set pixel which can do that for me safely. Yes, I think I will. So let's just quickly knock that together. So float get int x and int y. And this is going to do some precursory checking just to make sure it's in bounds. So if x is greater than or equal to 0 and x is less than n frame width and y is greater than or equal to 0, oh come on, and y is less than n frame height, then if that's all good, we want to return the relevant location. So return, this time it is pixels, y times n frame. So this is why I want to avoid typing all the time. Come on, help me out. N frame width plus x. Oh, by the way, I didn't mention it at the start of this video. If you've come over from the YouTube channel, I always have to mention this on my Twitch streams. You'll notice this is nothing like the YouTube channel. It's a lot more chaotic, it's more random, it's just me messing around, really. So do expect some awkward pauses and some bugs and all those good things. So we've got return pixels. No, there is no dot at the end of that. That's it. We're done. And if that's not the case, then we'll return 0. It's always a bit awkward to know in image processing whether you should return 0 or something else because 0 is an equally valid value. We'll worry about that if it becomes a problem. Equally, we need a set to go with this, and there'll be people giggling saying, "Oh, he's using getters and setters, and he made that video about getters and setters." Well, yes, but in this case, I think they're justified. So we'll have x, y, and float value for the pixel. And we want to do the same sort of thing. If that's valid, instead of reading the pixels this time, we want to set it. So it'll be p. And if it's not valid, then we don't do anything at all. Let's have a quick look. Good. Good to see that some people are here. So I'll just reiterate to those that have dropped in what's going on. This is I'm starting to do a few streams over the next sort of 10 days or so before my next YouTube video goes out. I just really wanted to document the process of how I go about coding up a YouTube video. From the idea, which was 8 bits of image processing you should know, to the final implementation. So the last part of this series will probably be a video of me creating a video of, well, me. a bit sort of Javidception. It's all a bit egotistical. I'm a bit wary of that. But it was for my own personal records, and I wanted to at least one instance where I've recorded the process. Right, so what were we doing? I've forgotten. We were thresholding an image, but we just created these getter and setter values. So we want to set the output value in those locations to the input value in the same locations, but we want to test the input value to see if it's greater than a particular threshold value. So in this case, I'm just going to choose 0.5. If it is, then give me a 1, and if it isn't, give me a 0. Now, I'll have to go away and think, is things such... I need to put a .set there, don't I? Are things like ternary operators, are they good for a video like this? Because is that clearer to the user that really wants to understand what a threshold is than doing it explicitly? And these are some of the choices I actually genuinely have to make. That's how I would like to do it. That's the inner programmer is saying that's the way to do it. But I've got to bear in mind that some of my audience aren't as skilled or aren't as experienced and may look at that and really not understand what's going on. But let's make it work first, and then maybe in the next part of this series we'll start to strip out some of the complexity, or we'll try and tidy things up. I think that's going to be. It is required by law to have getters and setters, just as you need abstract factories and interface. Yeah, well, we've got to go for the over-engineered, and then we comment all of it, yes. Working code is the first priority. That is absolutely correct. Sorry, I missed a notification there, but thank you for whatever that was. I can't currently see my Twitch output screen. It's a bit frustrating. My setup is a complete mess. The last few weeks have been quite tiresome. So we've thresholded the image. We've got width and height, and we've done the threshold. Shall we see if that works? Oh, we don't want to set the output to the input anymore because that definitely won't work. And I've set the value to be 0.5. Maybe none of the pixels will be larger than 0.5, so we won't see anything. Good. Well, it looks like the camera is doing some gain adjustment. That's probably why it looks so noisy. You might not be able to pick that up on the Twitch stream, but it is quite a noisy source image for me. And we've thresholded it, so things like my t-shirt here have lit up bright white, and things like my microphone have lit up dark. I got some sort of... Where am I looking? This camera here. So yeah, maybe I just need a little bit more light. A lot more light. There we go. Retro heaven. So threshold seems to be working just fine. I'm half tempted to perhaps lower the resolution so you can see the individual pixels in the image, because that's quite a useful thing when you want to start thinking about how image processing works. Blavid. Okay. Right, maybe yes. So let's just see if we can take up a bit more screen real estate. So it's not very often I use odd numbered pixel sizes, so watch it all fall apart now. I think that's just it's gone off the edge of the screen. So what I think I'll do potentially is halve those image sizes, but these are sort of the aesthetics and things I can worry about later when we get to some of the other parts. So threshold, okay, done. That was easy enough. So what's the next one? Motion detection. Okay, motion detection sounds horrifically complicated, but if you saw my augmented reality in the console video, you'll see it's actually really quite trivial, and that's why it makes an interesting bit. It's not like it doesn't require a whole video in its own right just to detect motion. So motion detection, well, motion implies that something spatial has changed temporally, right? That's sort of the definition of motion. There has to be a difference in space in time. And the in time bit is interesting because that means we've somehow got to store a record of some previous frame that's come in. So I'll just bang in another frame up here, previous input. And so whenever I've took my input frame, the first thing I'm going to do is, well, before I capture an input, I want to set my previous input to the current input. I quite like using the assignment operator in this instance. And motion detection is quite simple. So again, we're going to have to go through all of the pixels. So I can see already that we're starting to see patterns in how this works. So maybe there's a way of thinking about tidying up all of this so we don't have to do it each and every time. Maybe it's better to leave it in because it's explicit. It tells the user, hang on, we're going through all of the X and Y pixels. So that's a decision I'm going to have to make, an editorial decision before I start writing the code. We don't want a threshold anymore, so I'm not going to delete it. I'm just going to comment thresholding out. And we'll think about maybe wrapping these up in functions later. Will I cover dithering? If I was to do dithering, yeah, and I have actually got Dither Encode done, I would do it as a separate video. I wouldn't do it as this. I've really only got 3 or 4 minutes per bit to discuss the algorithm, and I think dithering is interesting. And it's interesting because I used to work with a particular type of image processing sensor, and it used to deliver dithered images to us, and we created an anti-dither algorithm, which is effectively a fancy blur. And it was quite impressive to see the data compression you could get between taking an image, dithering it to a certain number of colours, and then reconstructing it through blurring, and it was almost lossless in some instances. It was really impressive compression. What would it look like if you did temporary filter to the thresholded image? Well, these are things that we can start to explore once we've got a bit of a framework, but probably not that different because, and I know what the results of these things are going to look like before I do them. Motion detected images tend to look like edge detected images, and edge detected images tend to look like black and white images, so it might look a bit thresholded anyway. But anyway, where are we up to? So we're doing motion detection, and motion detection is very simple. For every pixel, we want to set it to the difference between the current input and the previous input, and that's where we get the temporal part of it. So input.get I, j subtracted. Well, we subtract from that. Let's get that right. Previous input dot get I, j. Now that has the potential to give us negative values, and that's bad because images with negative values, well, they start becoming a bit strange. So that should be motion detection. Very simple. So that makes it a nice bit. So I can put a bit on the OneNote and draw what's happening, and then we write it out in code, and then we go away and test it. So let's have a look at that. Okay, so I'm trying not to move, but as I move, we're looking at the differences. Now you can see my camera tripod popping in occasionally. That's just because as I move, I'm vibrating the camera on top of my TV, and because this is a high resolution image, I'll do a bit more motion. Because it's a high resolution image, it looks like it's getting an edge effect on the camera. So if I try and nudge that again, there we go. But it's a bit dark and gloomy again. Yeah, it's so easy and yet so elegant. And these start... It might not be intuitive right now as to how these things can be useful in your games, but they certainly can. Particularly, let's say you've created a landscape, procedurally generated it, and you wanted to enhance some of the features, because there's nothing now stopping us taking this image and using it in some way to highlight the original image. It's just all about clever blending then. So you sort of get 2 in 1 with motion detection. You get edge detect, and you get... well, you get motion. But it's not a true edge detect. And I'll tell you why it's not a true edge detect. We can actually do this if I get rid of the fabs and we clamp that to 0. So basically we're just going to be looking at 1/2 of the image. Let's just try that as a quick fix, because that might be an interesting side point that I can make to the camera as I'm going through. So we'll take the maximum of whatever that result is and 0. Now this, if it works, if I've coded this correctly, will give us some sort of interesting side effect. Yes, and it may be a bit tricky to see. What we now see is sort of motion in a direction. So you can see how the highlighting on my hand changes from one side to the other. Reminds me of the MP4 glitches. Well, you know, exactly, right? A lot of image processing is how you encode videos. And you only ever really need to send the information that's high frequency temporally as part of a video codec. And high frequency means the stuff that your brain's going to pick up on. Why do I need to transmit all of this wall every frame? There's nothing there. But as I'm talking and my mouth is moving and we can see the hairs in my beard, this is all high frequency information. That's the bit that's relevant to transmit. Anyway, I want the absolute image again, so I'm going to put that back. Because that's a bit more of a broader image processing algorithm. So now both sides of the motion are highlighted appropriately. Of course, I could, if I had the ability to display negative pixels, you can look at the motion sort of on both sides of the object by looking at its sign bit. But in this case, it's just there is motion happening in this region. Okay. Everything changed when the pixel benders attacked. I don't understand that, but sounds cool. Can you detect motion direction left to right? Yes, you can, with a little bit more effort. If you haven't seen my augmented reality video, that's the one to have a look at. Because that detects motion in 360 degrees. So it'll give you the direction of motion per pixel on a screen, and that's how I was able to control the ball and the shapes on the screen. That's actually quite a complicated thing, and that's why it required a video on its own right. Will I make a video about threads and futures? Maybe. I've tried to stay away from a lot of the C++ sort of nuts and bolts and mechanics of that sort of thing. Mainly because it's a way to open yourself up to nothing but criticism, because if you do it in a way that isn't how somebody else has learned how to do it, they're just going to shout at you. It's not that easy to make an interesting application that just shows threads. I mean, what do you show? You show it different threads performing a calculation. If I was to do it, I'd want to do, for example, take the balls physics, 2D balls, but having hundreds of thousands of balls all colliding at the same time, and how all of the interconnects between the threads work. And that takes a lot more work, and then the video becomes quite long because I've got to then start explaining how the physics are split up over the threads as well as just the mechanics of the threads. So there's a bit more to it. But never say never. I have got a plan this year to do well, at the moment it's a 10-part mini-series, and the videos are only going to be 6 minutes long each. But I'm not going to say anything more about that. Anyway, so we've got motion detection. So if I go really still, I can disappear. Now the problem with motion detection, if I just turn my light off, the noisy image, you might not be able to see it, but the noise, of course, turns up as motion, and that's a bad thing. Because now you're working with real-world data, which is never what you need it to be. I'll turn the light back on, mainly so I can see what I'm doing. It crisps the image up a little bit more. Can I use the header file you're using to get input from a phone camera linked via USB since I do not have a webcam? Maybe is the answer. I've not tried it, but as long as your computer recognizes the device as a webcam, it shouldn't have a problem. The header file essentially wraps up an ancient DirectX library to just find a video source and display it. Having said that, it doesn't work with my little cheapo action camera. Then again, not much does, as you can see with the syncing problem. So I wouldn't say it's any good there. One thing I will do, it does work with the PlayStation Eye cameras, PlayStation 3 Eye cameras, and they're exceptionally good cameras. If you ever see one of those on eBay, pick one up and start doing some image processing with it, because they do 180 frames per second at this resolution we're working at now. And they come with built-in hardware transforms, which you can easily access through the driver. Right, so we've done thresholding, we've done motion detection. What did I say was the next bit? Erosion and dilation. Right. So these are a little bit more tricky to start describing because now we've done sort of a dimensionless transform. We've now done a temporal transform. This is going to be a spatial transform. In fact, all of these from now on, except for low-pass filtering. Well, maybe we'll do low-pass filtering because that's a temporal transform that doesn't require any spatial information. So let's have a think about doing that one. I'm going to need, for temporal transformation, low-pass filtering. Let's put that in. Low-pass filtering. Low-pass filtering. I'll just comment that out. So for low-pass filtering, I actually need to update the state of a frame that I'm maintaining in memory, and I update it with a small part of the difference between that current frame and its input. And the idea is any high-frequency changes, such as fast motion, like this, disappear. But low plodding, sort of slow motions stay in the past. So it's a temporal low-pass filtering. Temporal low-pass filtering. Let's have a look at that. So I do know I'm going to need an additional frame on here for filtering. What am I going to call it? Activity. I'll call it activity. And so as the frame comes in, we're going to need a set of loops again. Temporal low-pass filtering. I'm going to go through every single pixel, and for our activity, maybe do I need to do it with activity? Do I even need the activity frame? I think I might not, but we'll see. Output.set I and j. So this is per pixel. There's no sort of cross-pixel communication required for this. This is just going to be in place, a bit like the thresholding was. I want to take the difference between what the input is, so input dot get I comma j, so it's looking a bit like the temporal one that we had before, but instead of taking the previous input, I want to take it from itself. So in this case, it's output dot get I comma j. I want to take all of that. Yes, I don't think I can do it just this simply. I think I might just break this out into a little, so we can see what's going on. So the difference in luminance value, let's call it DL, is going to be that. Input take, what have we got? Activity dot get I comma j. So that's giving us the difference in luminance between two successive frames, well, between the activity frame and the input. And I want to take that difference in luminance and multiply it by a small amount. So yes, I'll be able to, hang on a second, multiply that by, well, we'll pick a value for now, but I really don't know what it's going to be. I multiply that by a small amount, and then we add that to the output. Well, so we add that back to the activity. So activity dot set I comma j, that value dl plus activity dot get I comma j. So it looks like I might not actually need the activity flag, so activity frame. Do I need the activity frame? I don't think I do. Let's just try it without first. So let's get all that. So yes, a bit of a complex operation going on there. But what we're really trying to do is looking at what the current output is, how is it different to what our new input is, and take a small proportion of that input to adjust our output. So let's take a look at that. Now we might have to tune some of the values potentially, or it might just not work at all. Let's have a look. Is it working? Is it working? Oh, hello. Ah, right, it is working. So it did its thing. So you can see on the left that I'm talking, but on the right you can barely see that I'm moving at all. And if I lift up my arm here, you can see it takes time for my arm to appear in the screen. So if I do very fast movements, Maybe we can actually make this a bit longer. Okay. Now, if I shake my head from side to side, I can make my head disappear through the background. So we're not allowing this sort of high transient information through. Let's have a quick catch up with the chat. So let's find something with some high frequency edges on. Yeah, so it appears, and then if I move, yeah, I think we need to tweak the value. In fact, I think there's several algorithms here where we're going to have to tweak a value. So it might be worth putting some sort of information on the screen that allows you to change those values. But let's try a different temporal value. Now, why did it take so long to get started? Have I been stupid and left something in there which is causing it to be slow? I don't think I have. I think maybe our algorithm's just not very responsive. So I'm going to slow that down by a magnitude. So it might take a bit longer to get started this time. Might be worth on the first frame just priming it so that the same level, the output is set to input on the first iteration. So I can slowly see, you probably can't see it on Twitch, but the black background is slowly changing in intensity. It is very slow. You have to take my word for it. We're all stood staring at this black window. Slowly. Was an order of magnitude. So this is something I would make a bit of a mental note about. It's no good in my video if we're all sat here waiting for something to happen. Yeah, this is it. It's too slow to be sensible, that, isn't it? Let me just make sure. I've made sure I've not dropped a clanger with the maths here, really. Output.get is that plus a small bit. So if I make that larger, it was curious that it took so long the first time round. See, it goes whoop, pop. Right, so what I think we'll do is we'll prime the frames for the very first iteration. We'll just set the output to input. So I'm going to need a little boolean here. B prime equals false. We've grabbed an image. If not B primer, what we're doing, output equals input, just to set it once, and B primer equals true. I'm in bad typing mode tonight. So that just sets it once, and it should just set them to be parity, because I think what we're waiting for is just waiting for it forever to get there. I'm sure there's maybe something not quite right here, but let's have a look. Right, so okay, that primes it straight away. So let's go back to our original value. So yeah, that seems to be working okay. Now that's better for me in a video making context, that I can instantly switch on. There was still a bit of a dark delay there, wasn't there? Ah, that's just the camera's auto calibration kicking in. I quite like this time one because I'm talking away and you can barely see my mouth moving. One of the things you may also have noticed with temporal filtering, particularly this low pass filtering, I'm going to turn the light off again. Again, you might not be able to see it on the Twitch video, but look on the image on the left just how much noise there is compared to the image on the right. There is none. So this is a very useful noise filtering technique. I just want to set it to sort of be ghostly, really slow. Maybe that was just too slow before. So we primed it. So that's a really long filtered low pass function. So I bring this arm up. There we go. You can see it takes ages for my arm to get absorbed into the scene. But of course the downside is it also takes ages for it to go away. So let's say I'm interested in subtracting the background of a scene from an image. This is one way to do it because my background has remained static, but me in the foreground is still being motion. So this might be some sort of exciting thing we can try there, is to subtract the two images to give me motion that's not edge-based. It's actually motion for the region. So it's a different type of motion detection that we saw before. I wonder if there's a quick way we can sort of hack that together. I just want to see if it works. So once we've set the pixel, output has become our background image. Tell you what, I'm going to try it. Activity. Might need a bit of fine tuning to get working. So activity is the sort of background level that we're going to use. I'll put all of these back later. And our output is going to be what we had before with this motion detection. So in this case, output equals input this time, minus activity. Come on, select it. There we go. Activity. Let's have a look. Did I click play? I don't think I clicked play, did I? Not entirely sure that's the effect I was going for. However, it looks kind of cool. So it's sort of motion detection. Yeah, not quite what I was looking for there. And the reason being is when you've got grayscale images like this, my hand is not that dissimilar to the colour in the wall. So of course when I subtract them, it goes towards 0, and that's why my hand looks a bit, well, a bit ghostly. Also, this would be one of those interesting situations where you would want to look at the sign bit of the subtraction calculation, because then you can make a determination about what is foreground and what is background based on the sign bit. But I think we're getting carried away with ourselves for our 8-bit program. So I'm going to undo all of that and put it back to normal. And I liked the value. The 0.1 value is a nice one to have. Put my light back on. Very nice. So that's low-pass temporal filtering. And that's really used for getting rid of, well, pixel noise. I mean, I've exaggerated the effect here, but you'd be surprised how low you can get this value. So if we, well, how high we can get this value. If we set that to 0.5, that should be a really fast low-pass filter. So the images are, you can see a little bit of a blur, but it's still very up to date. But there's no now temporal pixel noise, or at least it's very much reduced. If any of you have watched Ugly Swedish Fisk's videos about his path tracing applications, this will be one of the techniques he's using to help with his blurring. At least I think it will be anyway. So what have we got next? What was the next bit? I'll put that back to 0.1, that's a good value. But mental note, we perhaps need a slider to start changing some of the values. Let's comment that out, we're done. What was another bit we can look at? Right, erosion and dilation. Okay, let's have a look at erosion and dilation then. So erosion and dilation, they're the same thing, but they're opposite. And so if you can do erosion, you can do dilation and vice versa. It just depends on what you consider to be positive and what is negative. So as usual, we're going to need a loop. Erosion and dilation. So this video tonight, for those that have just joined, I think I just got a thing then, didn't I? Ah. Mocking Matador, thank you for the follow, man, much appreciated. This video tonight is the start of several live streams I hope to capture over the next 10 days or so, which document how I go about making one of my YouTube videos. And tonight I'm just throwing the ideas out and trying them and making sure I understand what's going on. Fortunately, image processing is a topic I actually know something about. So that's why I can sort of whittle through these pretty quickly. Erosion and dilation. So what is this? The idea is we need to take a thresholded image. That's the most important part. We've got to have a threshold. Now instead of, I'll tell you what, I'm going to cut those comments back in. You can't do these without a thresholded image. So as I'm presenting this as a bit later on, I think it's important that you show both parts together. And the output, instead of setting it to output, I'm going to use my activity frame that we created. So it looks like I do need one temporary frame. Lajoff or Lajoff, thank you, man. Thank you for the follow. I can actually get rid of this document now, maybe. Let's just catch up with the chat because I see people are talking. This will be cool with complex numbers. It'd be masochistic, but yeah, it could be cool. Scary, you like these effects. Reminds me of Doctor Who. Caribou84. Oh, hello. Happy to catch a stream. Yes, and you'll see they are quite different from the YouTube streams. Far less organised. But following on YouTube, just watch the Twitch LCD episode. Yeah, it was a good one. I've done a lot more with the sort of Twitch command stuff over the recent months. And we have a stream that I do probably once a month called Game Decider, where the community get to decide which NES game my emulator plays, or whether to subject me to more punishment on the game that I'm currently playing. Might do one of those at the weekend. Not done one for a while. What are we doing? Erosion and dilation. Right, so the purpose of erosion and dilation is to expand or contract a threshold in image. So this is a purely spatial transform. There's no temporal properties involved. And we want to set our output. So it's not, I can't do it in a one-liner as conveniently as I did before. Oh, excuse me. Because what I need to check for is the activity in a given location. So if activity dot get I comma j is, well, if it's equal to 1, because we've thresholded it. So if a particular pixel is lit up, then which one are we going to do first? Let's do dilation first. If it's lit up, then we want to light up our neighbours. Simple as that. So if activity ij equals 1, then we want to set our output. Same thing, set I comma j to 1. Try and be consistent with my numeric labelling here, although it is a bit of a brain dump at the moment, this video. So we want to set that particular pixel to 1, but we also want to set our immediate 4 neighbours to 1. And it was a good job that I wrapped these things up in gets and sets, because now I don't really have to worry about the boundary conditions. What are we doing? So I minus 1, I plus 1, j minus 1, and j plus 1. If the activity is not set, then we want to set our output to 0. I comma j comma 0. So this is called dilation, and what we might see is we don't really see anything to begin with, but let's take a look. See what we've got. Right, so here I've thresholded in. I might actually be better off without the light on for this one. So we took a thresholded image, which we saw before, and for every lit up pixel, it's a curious pattern I'm seeing on the pixels there. I might have got my coordinates incorrectly. For a single lit up pixel, we also light up its neighbours. So I might need a toggle switch in order to switch this on and off. Yes, a curious pattern going on there. Have I messed something up there? It's kind of working, but also kind of not at the same time. But what we can do to help aid dilation is do it several times. I tell you why. Oh, we set our threshold to activity. Then we want to take our output. Once I've done that, I also then want to set our activity to, no, I don't want to do it there, do I? I want to do that down here. Activity equals output. And I want to dilate several times. 10's probably far too many. And here we begin to see one of the big problems with image processing is it explodes in computational complexity very quickly. So I'm going to dilate this 10 times. Each time I'm going to set the activity to be the output and then update the output. Let's have a look. Curious. Curious. Why are we getting all these little triangles for? What have I messed up here? Definitely shouldn't be getting triangles like that. Would you ever make a video on programming algorithms for backtesting prices in stocks and shares? It's a very specific video there. You want to play the stock market. Yeah, Standard Lib does have, rather bizarrely, and I've mentioned this on the Discord, why it has a complex number class, I don't know. Why can it justify having a complex number class and not other numeric types? Obviously, somebody on the committee just loved complex numbers and said, yeah, I need a type including here. It's a strange one that it's there. Right, I need to work out why am I getting lots of little triangles instead of the shapes that I'm expecting to get. If I wanted to deliberately draw triangles, I don't think I'd know how to do it. This is the fun part of now working on the videos, is you get to sit here in awkward silence whilst I stir at the code, hoping for inspiration as to why it's not doing the thing I'm expecting it to do. So I'm thresholding it, and that should be giving me an array of pixels. So we can test the theory here. Can I? No, I can't. I need to do it at least once. But it seems to be drawing triangles. Why are we drawing triangles? What obvious thing have I missed? We're going through each of the pixels. We're looking at the activity of a given pixel. Activity has been chosen from the threshold. If the activity is 1, then our output, we want to set the current output's location to 1. We want to set the pixel to the left of us, the pixel to the right of us, pixel above us, and the pixel below us. You get the debugging session. This is all the viewers disappear now. But this is a fact of life. This is how I spend most of my evenings sort of stirring at code, wondering why it's not working, and then thinking about how can I convince my viewers that I know what I'm talking about. Triangles. Why would I get triangles? It looks like I'm only setting things on one side of the shape. Have I messed up my set function? Set. If x is greater than that, then do that. Y seems okay. Triangles. Bizarre. Why am I getting triangles? So I can spawn, where am I going? Camera up there. So each one of these little dots over here will presumably be a starting point for a triangle to spawn. It must be something I'm doing overwriting the array. Curious. I find watching people debug code way more useful. It teaches me two things. I'm not the only person who ends up stirring at code. This is the reality of it. Good old triangle filter. There we go, guys. That's what I meant. That's the bit of image processing we'll have, though. It's the triangle filtering algorithm. It's really quite useful. So that's telling me that something is going on with my... hang on a sec. Bit of a brainwave coming through. So once I've scrolled through a pixel and I've set the output... See, the output is exclusive to the input. At least I think it is. Discovered Pythagoras in image processing. So why am I getting triangles? I don't know. I check the value of a pixel, and if that value is 1, I set the pixel above me, below me, left of me, and right of me. At least I think that's what I'm doing. Ah. Ah. Is it because when I get to this else, on the sides as I'm scrolling through... Ah, okay, that's it, isn't it? Right, so as I'm going from the image, I'm going from top left to bottom right. And as I've chosen the particular pixel and illuminated my neighbours, that's fine. But then it gets to the next one along, which doesn't activate. And so it sets that pixel, which could have been set on a previous iteration through the loop, a particular colour. So what we want to do is get away from that. And we could probably do that with a binary morphological convolution later on. But for now, let's just try and hack our way out of it, which would be to... Basically, if we're dilating, we want to set our output to our activity at the start. Yes. Output equals activity. So now we've set our output equal to our activity, so we don't need to do something if this is not true. So if the pixel is black, we don't do anything. Right, let's try that. We should see, hopefully, diamonds. Diamonds! Hooray! Haha! See, I do know what I'm talking about. Although I'm waving this at the wrong camera, of course, now, aren't I? I'm waving it, waving it up there. Right, so there we go. Let's put some light back on now. Right, so this is dilation. You might be thinking, well, what is this useful for? Well, exactly, no, good. I'm glad you agree. So the idea of dilation is that you take a single pixel and you expand it a certain number of times. You can see the frame rate's taken a hit here. Now, the frame rate's been limited to what my camera is capable of achieving, but this is a high resolution image. Well, it's not high, it's 320 by 240, and we're doing 10 operations on it. And so it's a nightmare for processor cache, but it's also, there's a lot of calculations going on there. So image processing is a bit of a CPU hog, no doubt. I mean, that's why graphics cards came along. But what is the purpose of dilation? Well, usually you use it in conjunction with erosion. So let's now just hack together erosion, learning from our mistakes. And erosion and dilation are pretty much exactly the same thing, except now, wherever we've got a black pixel, we set our neighbours to black, which has the effect of contracting the image together. So let's just have a look through this. So if activity equals 0 for this particular pixel, then I want to set my neighbours to 0. So let's just have a look at erosion on its own first. I've done 10 levels of erosion there, haven't I, by accident? Let's just do a single erosion so we can understand what the transform is doing. And so this is already telling me this is going to be a difficult bit to do in sort of a 3 or 4 minute chunk. So I have to now think of a narrative to help. So this has expanded the black regions, but decreased the white regions. I just want to show a regular thresholded image as well. So maybe this is a case where we do need to see more images on the screen. So for now, I just want to I'll tell you what I'll do. We will do that. We will create instead of our input image, we'll have our thresholded image. Threshold. And I'll just dump this in as well. So that was our threshold set. I'm going to keep activity where it is. So if I just set threshold equals activity, and instead of drawing input now, I'm going to draw the, need a semicolon thing. Instead of doing that, I'm going to draw threshold. You can see what the difference is. So on the left, I've got an image which is just the thresholded input of the camera. But on the right, I've got one where we have eroded the pixels. And erosion gets rid of single pixels if they are on their own. And so that has the effect of sort of tidying up the edges of the images, or making things like thin black lines a bit thicker. Good old Magetub and his monads. Right, so the purpose of these are called binary morphological processes. So the idea is we're changing the morphology of the image, and there's a whole subsection of algorithms which can do this, and there's some really cool ones, but certainly not ones I can describe in 3 or 4 minutes as part of a video. A really cool one is skeletonization, and I might actually just make a video on that in its own right because it's cool. I can hold my hand up in the camera like this, and you can see the skeleton going through my fingers. So that might just be a useful, fun video one day. Now, this is a sort of cheap way of doing erosion and dilation. The proper way to do erosion and dilation is to check, have I got any neighbours at all? If I've got neighbours, then I stay. If I've not got neighbours, then I disappear. Or we count how many neighbours a particular cell must have. In many ways, it becomes a bit like Conway's Game of Life. So let's have a look at modifying this sort of naive attempt at erosion into being something a bit more intelligent. And to do that, we need to look at our local neighborhood. And so right now, I'm just going to brain dump it again. I'll do it with, I'll do it with erosion. So I want to count how many of my neighbors have got 0 activity. Do I? No. I want the total accumulation of my neighbour's activity. If it's greater than 0, then I am connected to something, so I stay. I think that's what I'm trying to do anyway. So if let's add up some neighbours. So we need to do a few sums here. Float sum equals activity dot get. And we want to look at our immediate 4 neighbours. Just assume 4 connectivity for now. So it's basically what we've got there, but we're going to add them together. So this is why doing things in the floating point is suddenly quite useful. I take 1, j plus we got I plus 1, j. So that's left and right plus j take 1 plus j plus 1. So we've looked at our 4 neighbours and we've got a sum. And so what I'm going to try is, if the sum is equal to 0, so if I have no neighbours, then I'm going to set myself to 0. I think that's all I need to do, he says optimistically. Mastrup, thank you for the follow. I'm looking at these 2 images and they are absolutely no different from each other. At least I don't think they are. It's not if activity. It's if my activity is equal to, I'm getting confused in my own head now between which one's positive and which one's negative. So if my activity is equal to 0, now if my activity is equal to 1 and my sum is greater than 0, he wants to say, if my activity is 1 and my sum is equal to 0, then set myself to 0. Yes, okay. A bit difficult to see on a single iteration that we've got something there. So let's just increase the iteration count, I think. Let's put that back to 10. Don't think there's any difference there. What have we got? Is it if my activity is equal to 1 and the sum of my neighbours is equal to 0, then I'm setting myself to 0. Oh, I've got lots of stuff going on in the chat. Just a sec. Hey Plexum, thank you very much. That's very kind of you. Appreciate that very much. Does anyone know how safe it is to do straight equality with floats being 0? Yeah, not very. That could be part of the problem here. Unlikely. I mean, I'm definitely setting things to 1s and 0s, and you can certainly add 1 to 1 and get 2 as a floating point value quite accurately. So I'm not too concerned, but you're right, it's a valid concern to have. Technically you would check to see if the absolute value of this is less than a small threshold, usually called epsilon. So yes, you should never do direct equalities in floating point domain. But as I say, this is the first part of let's just get things working video. In fact, we're almost up to the end of the first part of let's get stuff working video. So I just want to see if I can nail this one. I want to get this I can't even remember. It's erosion. So the idea is we want to remove extraneous white pixels. So if I am white, I'm just trying to visualize in my head. If I'm a white pixel and I've got no neighbors, then I should set myself to nothing. But if I have got neighbors, I can effectively count how many neighbors I've got. So I've got to check for if I've got at least one neighbor, I stay. So maybe we want if sum is greater than 0. So if I'm active and I have a neighbor, ooh, strange. I don't know what filtering's done there. Let's just set that back down to 1 so we can explore it on a boundary level around the screen. Yeah. Looks to me like a perfect time to think about ending the stream. But what I wanted to capture in this particular stream tonight is this is the exact process that I have to go through, sort of night by night, trying to think of how am I going to present these code and get them working in such a way that's interesting and entertaining and informative. And I hope it also demonstrates that when I've got a project like Car Crime City, the top-down city-based car crime game, how here we're just trying to get the black and white pixels to appear on the screen. When you start thinking in full terms of 3D, there's a lot of work goes into it. So this is the first part. I'll try and get a few more streams in over the next week showing the progress. But what I will assure you is I won't code any more, not on stream. So I think YouTube is really hard work. Yeah, typically it takes about... on average per video it can take anywhere between 20 and 40 hours, including the filming and the editing. So thank you guys for watching. I appreciate that. I don't know if anybody else that's regular on the Discord has got a stream on the go at the moment. I don't think they have, so I've got nowhere to pass you on to. But I will see you very soon. Take care everybody. Have a very good night.